Good afternoon. My name is Steve Seymour. I am a solutions architect and a networking specialist, and I'm based in London in the UK. So first of all, thank you very much for welcoming me to Korea. This session is going to be a deep dive into Direct Connect and VPN. First of all, what is Direct Connect? What is VPN? Well, first of all, both of them allow you to establish a secure connection between your network and AWS. A VPN is quite simply a pair of IPsec tunnels that run over the internet, whereas Direct Connect is a dedicated fiber connection between your network and AWS. We charge for data transfer at a lower rate on Direct Connect, and our recommendation for high availability would be that you should use both. So for this session, I'm going to be talking about both types of VPN that we have and Direct Connect in both an active state and an active passive state. So first of all, some basics. Let's talk about Amazon VPC, something I hope you're very familiar with. This is a typical VPC. We have the region, we have the VPC within it. We have two availability zones within the region. And then within those availability zones, we have some subnets. All of this is standard VPC. But I wanted to highlight two things. First of all, that we can only have one virtual gateway attached to the VPC. And then secondly, that all of the functions that we're going to be talking about in this session require us to modify the routing tables. So as you can see, here is a route table that we're using in our VPC, and we're going to be modifying that to use Direct Connect and VPN. But what about the other services that we have, the things that are outside of VPC? So at the bottom here, we have the VPC we just looked at, but above it, we have some of the other services which exist outside of the VPC. Services such as Amazon S3, Amazon Glacier, SQS. These are all services which have public IP addresses. How do we access those? So this is the environment that we're going to be talking about during this session. On the left-hand side, we have the VPC running inside AWS, your private cloud within the AWS environment. On the right-hand side, we have your network, your corporate data center. And for all of the slides, we keep these two on those sides. These are the terms that we're going to be using throughout this session, the toolbox, if you like. We're going to be talking about, obviously, VPC, virtual private cloud, the route tables that I mentioned a moment ago, but also the internet gateway, the virtual gateway, VPN connections, Direct Connect, customer gateways. But in these slides, I refer to them by their acronym. So we have IGW, VGW, CGW. So first of all, let's talk about the VPN solution that we have. Within the VPN that AWS provides, we have two options for configuration. But first of all, what is a VPN? This is the definition of an IPsec VPN according to Wikipedia. The things that matter, though, it secures IP connectivity. It allows you to authenticate and encrypt every packet. It provides methods for mutual authentication. And finally, it provides a method for exchanging cryptographic keys. That is what an IPsec VPN is. And an AWS VPN is a completely standard IPsec VPN. But we do have two versions. We have static VPNs and we have dynamic VPNs. When you have a static VPN, it's very important that you define the routes. So you have to define static routes when you configure a static VPN. However, if you use a dynamic VPN, we use BGP, then we can exchange up to 100 prefixes, so 100 routes over that VPN connection. And we're going to talk about both of these. So these are the requirements. You can find these on the AWS website. These are the details for the AWS VPN solution. The key things are that VPN connections must be initiated from the customer end of the connection. We use a pre-shared key to authenticate each end of the connection. We then support AES 128, 256, SHA-1, SHA-256. These are all standards in the VPN world. Various options for PFS, and interestingly, we now support NAT traversal at the bottom here. So these are the standard requirements. How does it work? Well, it's quite simple. When you create a VPN in AWS, we will always provide you with 2 tunnels for your VPN. So you can see on the left-hand side, we have 2 endpoints for every VPN, even though you may only have 1 on your side. So you create a VPN, you have 2 tunnels. Now we have to exchange routing information. Well, for a static VPN, we have to define that in advance. And if you only have one simple network, 192.168, on your side, this is really simple. It's called one security association on each tunnel to exchange that encryption information. But what if you have more than one network on your side of the connection? The way the AWS VPN works is we only support a single security association in each direction on each tunnel. So if you now have multiple networks on your customer end of the connection, and you try to build a security association for each one of them, only the first one is going to work. So as you can see here, you might have unpredictable behavior. This is not good. If you're configuring this on your network, this is the better way to configure it. Configure your security associations for any on each side, and then use network ACLs to control that traffic. So if you don't want to allow certain traffic over your VPN, that's fine. Just put a network ACL in place to block it. You can then filter that unwanted traffic. So this is a good static VPN configuration. What about dynamic VPNs? So the key thing about a dynamic VPN is we use BGP to exchange routing information between the 2 ends of our VPN connection. What is BGP? Well, you can read it here on the slide, but basically it's a protocol for exchanging routing information. It's TCP-based, which means if something goes wrong, the TCP session will get torn down and the routes can be withdrawn. We have BGP neighbors that exchange information on each end of the VPN connection. And then we have a set of rules for choosing which routes to prefer. We use autonomous system numbers, AS numbers. And with AWS, you're using eBGP. This means the 2 AS numbers on each end of the connection are different. And then finally, we use AS paths to measure the distance between networks. And you can use local preference to control which of many connections to AWS you use. So these are the terms that I'll be using for the rest of this deck. So dynamic VPN. Again, it looks similar. We have 2 endpoints on the AWS side. So every time you create a VPN, you get 2 tunnels. But in this case, there's an IP address for each end of the tunnel. And between those 2 IP addresses, we're going to establish a BGP session. From the AWS side, we will announce a single prefix. We're going to announce 10.0.0.0/16 for this example VPC. From the customer side, you can announce whatever networks you like to us, up to 100. As I said at the beginning, though, once you put this VPN in place, you still need to modify the route table. So once the VPN is up and running, you need to go to your route table inside your VPC and add a route for your remote network and say that the target is the VGW. So now all traffic for your network routes via the VGW and then over one of the VPN tunnels. Pretty standard stuff. When you create a dynamic VPN, we automatically allocate the IP addresses for each end of the VPN connection. You can choose the AS number that you use. It can be one that you own, or it can be one of the private ASNs. It doesn't matter, you can choose. On our end, the AS number is fixed. It may be different for different regions, but for your region, it will be fixed. Now, inside the virtual gateway, if we have multiple ways of connecting to your network, we will need to decide which one to use. This is the path selection process that we have. So first of all, we will always choose the most specific prefix, also known as longest prefix match. Assuming that we have multiple paths to the same prefix, the next thing we do is we will choose Direct Connect. Direct Connect is that dedicated fiber connection from your network to ours, so we will prefer Direct Connect before we prefer VPNs. And then as you can see, we work our way down. We have static VPNs first, then we have dynamic VPNs, And then finally, we look at the AS path. So how many hops across the networks is it to get to that particular destination? This is the path selection process. So I talked about AWS having 2 endpoints for our VPN. But what about on your customer side? What if you have 2 routers, 2 customer gateways, and you want to have some resilience as well? Well, this is very simple to configure. You simply create 2 VPN connections to AWS. You end up with 4 tunnels, so the blue and the green. And in your network, you may need to exchange routing information between those routers. So maybe something like OSPF. It's your choice in your network. The next stage to a resilient connection is what if you have multiple VPCs? So now on the left-hand side, we have 2 VPCs. Again, this is still quite simple. You just build a pair of VPN connections to each of your VPCs. So now you have a resilient connection to 2 VPCs at AWS. Okay, let's talk about Direct Connect. What is Direct Connect? Well, first of all, it's a dedicated private connection into the AWS network. It allows you to create 2 types of virtual interface, public and private. It provides you with reduced data transfer costs, so typically about 1/3 of the price of internet data transfer. It provides you with consistent network performance, so the performance that you get on day 1 is the performance that you will continue to get. All of the AWS regions have at least 1 Direct Connect location. And you can always install multiple Direct Connect connections for redundancy. An important example that I'm going to talk about later is the fact that you can share 1 Direct Connect connection across multiple accounts. And in the US, we have the option to share routes between our different regions, but that's only in the US. Quite simply, Direct Connect uses BGP to exchange routing information over a VLAN, and we're going to look at that in more detail now. So first of all, here are the Direct Connect locations. These are all on the website. The one for the region here in Seoul is at KINX, but as you can see, various regions have various amounts of Direct Connect locations. What are the components of Direct Connect? Well, the first thing is the physical connection. It's a fiber connection between your network and AWS. And you're going to see terms such as leased line, pseudo wire, LAN extension. Basically, this is all referring to a physical connection. This might be an example of a customer connection. In this case, 2 routers connected to Direct Connect. As you can see, it's physical equipment in a rack, and it is single mode fiber that we use to connect to your network. You can either connect at 1 gigabit, which is 1000 base LX, or at 10 gig, at 10G base LR. These are just 2 standards of fiber connectivity. If you don't have a presence at the Direct Connect location, you may work with a partner. So maybe a telecoms provider, a carrier, may get that connection from our Direct Connect location to your network. And then there's always going to be your equipment, your customer router. So what does that look like? Well, we have our VPC here on the left, our AWS environment. We have a Direct Connect location. And within it, you could quite simply choose to co-locate your equipment in the Direct Connect location. Our network comes as far as the Direct Connect routers. That's where the AWS demarcation point is. Everything past that is your network. So in this case, you have your routers in the Direct Connect location and your network back into the rest of your data centers. If you're using a partner, though, you may not have your own equipment in the Direct Connect location. That may be a partner's equipment, and in which case the partner is now responsible for that network from the Direct Connect location through to wherever they connect into your data centers. So it's a very similar setup. It's just the partner's equipment in the data center. Now, this may take you back to school, perhaps some early study, but this is the OSI model. On the left-hand side, we have the layers. On the right-hand side, we have what is it really? So layer 1, the physical connection. Well, it's a single-mode piece of fiber. Layer 2, it's VLANs. That's what we care about in terms of Direct Connect. And you can see the other layers here. We build our way up to the ability to route traffic at the top. How does that map onto Direct Connect? Well, quite simply, we take the single-mode fiber connection here at the bottom, and in the console, we refer to this as a Direct Connect connection. We then have something in the console called a virtual interface, public and private. Well, this is quite simply a combination of VLANs, IP addressing for each end of the connection, and a BGP session. Then at the top of the stack, we have the virtual private gateway, which is what enables you to route traffic to and from your VPC. All of this can be owned by a single account. So what are these virtual interfaces that I've mentioned a few times? Both public and private, they both use 802.1q VLANs. They both use an eBGP session to exchange routing information. Now, we only support BGP on Direct Connect. We don't support static routes. We don't support OSPF. Only BGP. A private virtual interface will give you access to your VPC. A public virtual interface will give you access to all of the other services that are outside the VPC, services such as Amazon S3 and Glacier, as I mentioned earlier. Back to this chart. We still have the connection here at the bottom, but this is illustrating that you can take a single Direct Connect connection in one account and share it with all of your other AWS accounts. So when you create a virtual interface and share it to another account, it's called a hosted virtual interface. Still all of the same configuration, but now you can use it in two different accounts. One further variation is if you take a smaller amount of bandwidth than 1 gig. So if you're going to use 50, 1, 2, 3, 4, or 500 meg, you can obtain that service from a partner. Now, in this case, the partner has an interconnect with AWS. They will provision a VLAN and an amount of bandwidth for you, and then in your customer console, you will see a hosted connection. So this is for smaller amounts of bandwidth, less than 1 gig or 10 gig. Further, you can still share that connection. So you now have a hosted connection from a partner in account number 1, and you can then share that into another customer account. So you can do this whether it is a smaller amount of bandwidth or one of the larger amounts. You can share a Direct Connect connection. So private virtual interfaces. As I said, these provide you with access to resources that are running inside your VPC. It doesn't give you the ability to access things like VPC endpoints or traverse peering connections. It just gives you access to EC2 within your VPC. It attaches to the virtual gateway, so the same place that the VPN attaches to. Remember, we only have one of those attached to our VPC. But you can use multiple private virtual interfaces if you want resilience. So if you have 2 connections, you could have 2 virtual interfaces, both attached to the same virtual gateway. And finally, because this is all private, you can actually use any IP addresses and any AS number that you like. It's all private. So how do we configure this? Well, once again, we have our VPC on the left with our virtual gateway and our customer network on the right-hand side. Now, when we configure this, we're going to create a virtual interface, DXVIF, and we're going to choose a VLAN. Once we have a VLAN, we need some IP addressing to exchange our routing information. We have an AS number for each end of the connection, and finally an MD5 key for authenticating the session. Once we configure that, the BGP session will come up. From the AWS side, we will now announce 10.000/16. From the customer side, you can announce whatever you like, up to 100 prefixes. So in this example, 172.16. The two are now exchanging routing information. The virtual gateway knows how to talk to your network. But we still have one more thing to do. We need to update the route table again. Now, we have an option on the route tables which is called propagation. And what this says is, take any routes that the virtual gateway has received, either VPN or Direct Connect, and automatically put them into the route table. And this is very useful when we're doing dynamic routing using BGP. It means that as we announce a route or we change the customer network over here, those changes automatically appear inside the route table. So, Werner Vogels, CTO of Amazon.com, he said everything fails all the time. So we need to plan for things to go wrong. So for Direct Connect, what can we do? Well, first of all, every Direct Connect location that we have has at least 2 sets of routers on the Amazon side. So you can always create multiple connections. So in this case, we have 2 routers, both connecting into your single customer router, but you now have some resilience across multiple pieces of Amazon equipment. The rest of the network is exactly the same. But how do we configure this? We're going to need to create multiple virtual interfaces. So we're going to create 2 private virtual interfaces, 1 on each connection. This is what it looks like. It looks pretty similar to how I talked about it a moment ago. We just have 2 of them now. So there is still a VLAN, there is still an IP address, still an AS number, and an MD5 key. The thing is, we need to make sure that the IP addresses are different, though. Because both of them are going to attach to the same virtual gateway, the IP addresses that we used must be different. However, it depends on your router on this side, but you could use the same VLAN ID. The VLANs are isolated per Direct Connect connection, so you can reuse the same one if you like. So let's go back to this picture. We have our resilient connection. There's clearly something very wrong with this, though. We have a single customer router. So a much better design would be this, where now we have 2 connections going to 2 different customer routers. But furthermore, we've then carried that across the service provider, the carrier network, all the way back to your data center. So we now have a resilient connection all the way through from AWS to your network. But it all flows through that single location. So what's the next best level of resilience? Well, for some of our regions, we have multiple Direct Connect locations. So we now have 2 different buildings that our equipment is within. So at this point, you could move one of your 2 connections into the other location. Again, bring it back across the carrier network and have a nice resilient connection back to your network. So now you can deal with any potential failure of a building. And obviously, a final level of resilience is to put 4 connections in. Some customers do this. It's your choice. So how do we configure this? We have 2 virtual interfaces. A virtual interface is also known as a VIF, VIF. In the top example here, we have our 2 virtual interfaces. We're receiving a BGP announcement for 10.0.0.0 from AWS, and they're both the same. So we're just going to pick one in the customer network and just use that connection. If you have 2 connections, though, it would be much better if we could use both of them and run active-active. So with a simple configuration change on your customer router, this is a Cisco example, maximum paths 2. Now we have the letter M has appeared at the bottom. This says we're now doing multipath. We are sharing the traffic across 2 connections. Very easy to configure. That's how you do it on the customer end of the connection. On the AWS side, however, we see 2 paths to your network as well. We will automatically do the same thing. We will automatically do multipath, and we will use both connections and load balance across them. This is the standard configuration when you have multiple virtual interfaces. What if you want to run active-passive, though? You don't want to run across both connections at the same time. Well, in this case, on your router, you need to configure something called local preference. Now, again, this is a Cisco example, but it applies to all manufacturers of routers. In this case, we're going to create a local preference of 200 and 150. And now when we receive those routes from AWS into the customer router, we attach that preference. As you can see now, we have an arrow next to the 200 line. We're going to prefer the higher local preference number. And if for some reason that fails, we then fall back to the other one. But on the AWS side, everything's still the same. So it's still going to do multipath. There's no difference. So this is not good. We now have you as a customer sending traffic to us on one connection, and from an AWS perspective, we're sending traffic on both connections. We need to fix that. So how do we do that? Well, quite simply, this goes back onto your router. You use AS prepending, and what this means is you make one of the two connections look longer than the other. So we're going to prepend once or prepend twice. So we're going to put our AS number, 65501, onto the announcement once or twice. Well, if we now go back to AWS, these two look different. We have one which has 3 AS hops, and one of them has 2. So now, AWS will choose the shortest path. So we're going to choose number 2. So now we're running in an active-passive configuration. So public virtual interfaces. Public virtual interfaces connect you to those services which are outside your VPC. For this BGP session, we need you to use public IP addressing. Now, if you have your own public IP addresses to use for this, that's great. You can use those. If you need us to provide you with some public IP addresses for this BGP session, we're happy to do that. Just raise a ticket with support, and we will assign you a /31 of IP addresses to use for this BGP session. You use a public AS number, ideally. If you have one, feel free to use it, but it must be owned by you. If you don't have a public AS number, that's fine. You can use some of the private reserved AS numbers as well. And in the US, as I mentioned earlier, a public virtual interface gives you access to all of the US regions, but this is only in the US. So what does it look like when we configure a virtual interface? This time, a public one. Well, it looks pretty similar. It's still a DXVIF. It still has a VLAN, different one this time. It has public IP addresses, though, for the peering session. It may have a different AS number on the Amazon side. So it may be 7224, whereas for a private, it may have been 9059, as an example. There's still an MD5 key, though, for authenticating the session. But a key difference here is rather than receiving a single prefix from AWS, we're going to be announcing all of the prefixes for the AWS region. So this could be 10, 20, 50, 100, depends on the region. From your side of the connection, from the customer, you can announce to us your public IP addresses, and we will verify that you own those public IP addresses before we allow you to announce them to us. So this is what a public virtual interface looks like. Here's an example of the routing table that you receive when you peer with the Ireland region. So this is the nearest region to me in London, and this is an example of all of the prefixes that we announce from Ireland. It's currently about 99. So how do you order Direct Connect? What is the process to get it installed to connect to your network? Well, there are 6 steps. And the first one, and it's really important, is to choose the correct region. The amount of people that I have spoken to that have ordered a Direct Connect on the other side of the planet by mistake, make sure you choose the right region. Next, in the console, you're going to click the button that says Create a Connection. You choose the location that you want that connection to be present in, and then you click Submit. Within 72 hours, we will then issue you an LOA CFA. This is an example of it. It's a letter of authorization connecting facility assignment. And what that means is, this is the port on the Amazon routers that you're allowed to connect to. More accurately, that the location provider will connect you to when they do a cross-connect. So now that we know where the port is, the next step is to order the connection between your equipment and AWS. This is called a cross-connect. And then you can configure the virtual interfaces. Now, if this is a 1 or a 10 gig connection, you can create as many virtual interfaces as you like. If it's less than 1 gig, the 50, 1, 2, 3, 4, 500 meg connections, you can create a single virtual interface. And if you need more, you need to go back to the partner and order another hosted connection. Once that's done, you obviously need to configure your router. Now, both for VPN and Direct Connect, we give you the option to download the configuration for your router. We have some examples for various vendors, and you can then just install these onto your routers if you like. I would suggest that you edit them first and personalize them, but we do provide you with those example configurations. The process is slightly different if you're ordering a smaller amount of bandwidth from a partner. In this case, you go to the partner first, and you give them your AWS account number. It's a 12-digit account number. They will then create a hosted connection for you at the bandwidth that you ordered, and it will then show up in your console. You then click Accept Hosted Connection. Now it's the same, the final two steps. Create a virtual interface and configure your router. Now, we talked earlier about planning for things to go wrong. What if we want to have some backup to our Direct Connect? So in this case, we have two virtual interfaces going over two connections to two different Direct Connect locations. This is a good availability story. But let's make sure we have a backup over a VPN as well. Now remember, all of these connections all terminate on the VGW. So this is quite simple. On your side, you could have one router, it could be multiple routers, you have a VPN connection and the virtual interfaces, and you then configure your equipment to prefer the Direct Connects. On the AWS side, remember that we always prefer Direct Connect over VPN, so that happens automatically. One further request I often hear from customers is, I would like to encrypt my Direct Connect. How do I do that? Well, this is actually a very easy configuration to achieve. First of all, you build a public virtual interface, the blue line on here. And within the announcement for a public virtual interface, we actually announce the IP addresses for the VPN. So now, over the top of a public virtual interface, you can actually run an IPsec VPN, at which point you're getting the consistent performance that Direct Connect brings, but also an encrypted connection. So I see this being configured by customers quite often, but you now have three things to configure. You have the public virtual interface and the two tunnels. So how do we charge for these services? Well, first of all, VPN connections are charged based on what we call connection hours. What this means is when you create a VPN connection, we start charging you for it, whether you're using it or not. We then charge for data transfer over that VPN at the same rates as if it was going across the internet. Direct Connect is slightly different. We charge you for the port hours, and what this means is when you create a Direct Connect connection, it may take you a few weeks to get the equipment in place, to install all of the connectivity, but we don't start charging you until that connection comes up for the first time. Once it has come up, we start charging you for the amount of hours that that connection is now available to you, whether you're using it or not. But we also provide you with reduced data transfer rates. So if your data transfers over Direct Connect, it's a lot less than transferring over the internet. And finally, if you do the last diagram that I showed, where you're running a VPN over a public virtual interface, you'll benefit from the reduced rate of data transfer that Direct Connect provides. So a couple of things to remember. First of all Direct Connect locations are in a third-party facility, so at KINX here in Seoul. You are going to have to work with someone else to achieve a connection. It might just be the data center provider, but it might also be a carrier, a partner. There's always more than one organization involved. If you create a sub 1 gig, less than 1 gig connection, it will only support a single virtual interface. You may need to order multiple hosted connections. But remember, you can always share virtual interfaces between accounts. So if you have a 1 gig connection, you can create as many virtual interfaces as you like for all of your different accounts, perhaps development, test, production. They can all use the same one. And remember that public virtual interfaces do also include the IP addresses for our hardware VPN endpoints, so you can establish this encrypted connection. Now we have a few minutes left, so what I thought I would show you is a setup that we have in the lab for Direct Connect. So on the left, we have a VPC, and we have an instance running inside that VPC. On the right-hand side, we have a data center with a router. And at the moment, I have a VPN connection configured between the two of those. So this is the AWS console. If we go to Direct Connect, this is in the Ireland region. You'll see that we have a virtual interface. but its status is down. It's not configured at the moment. Okay? If we now go and have a look at the router, and have a look at our BGP sessions, we have 2 BGP sessions here which are connected over my VPN. At the bottom here, we have an EC2 instance, and this is a server at the data center, and they're pinging each other. You can see that the response time is about 13 milliseconds, running over VPN over the internet. It's not bad. It could vary quite a lot depending on how the internet is behaving that day, but it's 13 milliseconds. Now, on my router, I also have a Direct Connect. And what I'm going to do is just enable that interface on the router. Now, what you should see here is the BGP sessions will come up. So first of all, the interface has come up. We now have a BGP session running, which is our private virtual interface. And if you now see, our response time has dropped. So we've gone down from 12 or 13 milliseconds down to 11 milliseconds. On this router, I can also now have a look at the routing table and see that I have multiple ways of reaching my VPC. I have preference 200, which is Direct Connect, preference 100, which is VPN. So you can see on the left-hand side here, I prefer my Direct Connect. And then all of these other prefixes are the public prefixes being received over a public virtual interface. So that's what Direct Connect looks like when it's configured. After this session, I'm going to be outside on the AWS stand. So if you want to come and have a conversation with me about any more of the details, I'd be happy to have that discussion with you. With that, I would like to say thank you very much for coming to this session. If you have some feedback, we'd be happy to receive it. My name is Steve Seymour, and you can meet me outside. Thank you.